Hello guys, in this video we will be covering F equals MA competition A 2020, problems 1 through 3. So for our first problem, we have a coin of mass m is dropped straight down from a tall building. As it approaches terminal speed, what is true about the net force on the coin? So essentially we have the building right here. The coin is going down, and already we know that there's a force mg acting toward it downwards. That's by gravity. So we can immediately eliminate A. This is also 0 because it's not at terminal velocity yet. And now someone might think that it might be D because it says equal to mg. But we have to remember that because it's approaching terminal speed, that means that there's probably air resistance. So there's some force of drag. And since this is counteracting this force of gravity, we get that it has to be less than mg. That is why C is correct. A mass of 3m moving at speed v collides with a mass of m moving directly toward it, also at speed v. If the collision is completely elastic, the total kinetic energy after the collision is Ke. If the two masses stick together, the total kinetic energy after the collision is Ks. What is the ratio of Ke to Ks? Okay. For this we have 3m. Going in speed v, block of mass m, remember this is not drawn to scale, also going at speed v. Now if the collision is completely elastic, that's essentially saying that there's conservation of kinetic energy. So that leaves Ke as 1/2 3m v squared plus 1/2 m v squared, which is essentially 1/2 4m v squared, which is equal to 2mv squared. So now we essentially just need to find the kinetic energy, assuming that the masses are in an inelastic collision. So to do that, we could use conservation of momentum. So we have from this image above, conservation of momentum, initially, let's see, we have 3mv minus mv. Since the masses stick together, the total mass after the collision will be 3m plus m, which is 4m, and it'll be moving at velocity v1. So this basically means we have 2mv equals 4m v1. We have v1 equals v over 2. And now essentially we could just write the same kinetic energy, 1/2. Remember, they're stuck together, so it's 4m v squared, v over 2 squared, because it's v1 squared. And this is 2m v squared over 4, which is equal to 1/2 mv squared. which is equal to Ks. So now essentially we just had to divide these two things. So what we can do, so we need to divide KE by KS. So that's just 2mv squared divided by half mv squared equals KE over KS. And we have these terms cancel, and 2 divided by 0.5 or 1/2 equals 4. Yeah, so this is of course going to be E. Now let's move on to the third and final problem. A block of mass m is launched horizontally onto a curved wedge of mass m at velocity v. What is the maximum height reached by the block after it shoots off the vertical segment of the wedge? Assume all surfaces are frictionless. Both the block and the curved wedge are free to move, but the curved wedge does not tilt or topple. So here we can essentially see a conservation of energy. Yeah. And basically conservation of momentum. And the reasoning why is we can have the initial kinetic energy. So K KE equals 1/2 mv squared, right? And K final also equals 1/2 mv squared. And then we could use conservation of momentum. So this is cons energy. Yeah, so essentially we have an inelastic collision when this mass m is stuck or sliding along this path. Let me change the color. Sliding along this path is essentially going to be an inelastic collision. So what we have is mv equals little m plus big M, which is the mass of the structure, and then V1. And we can expect this V1 to be like quite small, smaller than V. So we have mv over m plus m equals V1. Yeah. So now we could just use conservation of energy again. Essentially we have, or KE initial equals, or equals 1/2 mv squared. K inelastic equals 1/2 m plus big M. Because remember, we're talking about the total mass. This is during the inelastic collision. Times V1 squared. And V1 is mv over m plus m. M plus big M. And this squared. And essentially, we just want to subtract these, right? Because we're going to have KE minus K inelastic equals mgh. So how to do this? Well, we could just common denominatorify. So we have 1/2 m Yeah, so we multiply the numerator and denominator of this KE by M plus big M. And this way, when we subtract K inelastic, we just have this. M squared V squared over M plus M, and this whole thing squared. And now this means that this goes away and this power also goes away. And so we have 1/2. And now we can expand this. Right here we get M squared plus M over M plus big M minus M squared over M plus M. Now we can close this parentheses. This is the total mass, essentially. And then finally we have both terms. Oh yeah, I forgot to put V squared right here. Yeah, but there should be V squared here. Yeah. So now we have these two things right here. We write that at the end, V squared. And now we notice that this cancels, this cancels. So we are left with 1/2 M big M over M plus big M V squared equals MGH. This M goes away. And then we divide by G. So now we have V squared. So we can put V over 2, right? So V squared over 2, and since we divided by G, because we want H, we have G that comes down here, times M, like big M, over M plus M. And this is our final answer, which is E. And as you can see, it's correct. So, if you enjoyed the video, please smash the like button and subscribe, just like I'm about to do on this unfortunate enemy tank. Auf der einen ein kleines